In this video we are going to talk about motion. Why motion is important? Because anything that happens in our reality happens because there is motion. If there is no motion, nothing happens. So the first starting point in this course is to understand motion. Understanding motion will allow us to predict in some way what will happen. You have to take in account that meanwhile we are talking, motion is happening. The sun is rotating around the galaxy. The Earth is rotating around the sun. You are rotating with the Earth around the sun. The molecules of the chair that you are sitting down, they are vibrating, they are moving. Everything is moving around you. Now, to happen the motion needs two ingredients. The first ingredient is space, and the second ingredient is time. We really don't know how to define exactly space and time, but we know how to measure space and time. The unit of space are meters, and the unit of time are seconds. So everything that you measure, if it's a space, you will measure in meters. If it's time, you will measure in seconds. The definition of what is a second is something that you can read in your textbook. We will start studying the motion in a straight line. One thing that is important is to realize that motion is relative to the observer. What it means exactly this? Depending on the observer, you observe one motion or you don't observe any motion. Motion is relative to the observer. Suppose the observer is placed at the sun. He will observe the motion of the Earth in a complete circle. This is almost a circle. Even this is almost a circle. Indeed, it's an ellipsis with the sun at the focus. But imagine that it's a circle. So the motion that an observer that is being placed at the sun will observe of the Earth and of this planet, is Mars, it will be two circles, we can say, two circles. The first circles delay 360 days to make one round. The second planet will delay almost double, 687 days to perform one round around the sun. So meanwhile, an observer that is at the sun will observe almost a circle of the trajectory that the Earth will do and of the trajectory that the planet Mars will do. What happens now if we change the observer and we place the observer not at the sun? We place the observer at the Earth. He will see the Mars going around in a circle around him. He will see this big circle around the sun. What he will see if you place the observer at the Earth. If you place the observer at the Earth, what he will see is a complicated motion. Let's go to analyze this complicated motion. Let's go to see how complicated can be the motion of Mars when you observe it from the Earth. Imagine that you are at the Earth. This is Mars. Initially, imagine that this is the initial position of the two planets. So you will see the object in this direction, and you will see with a certain distance, that will be this distance. After time passing, the Earth will perform a rotation around the sun, he will rotate, let's say, 1/8 of the revolution, but this planet goes slower. So he will rotate, instead of 1/8 of the revolution, he will rotate 1/16 of the revolution. So he will see the observer that is on the Earth, he will see the planet here. After sometimes when he perform a quarter, when the Earth perform a quarter of the revolution, the Mars will perform, let's say, a quarter, an eighth of the revolution. So it will be like this. So from the Earth you will see the planet in this direction, Let's go to put the line in this direction. So you see here, you would see in this direction. So what happened that from here to here, you will see the planet moving to the right. You see the rotation is to the right and going further. From here to here, you will see the planet going further, but now it's moving to the left, to your left. Now it's moving to your left and further. Now it's moving to your left and further. So if you do this and you try to see what is the complicated motion that Mars is doing around the Earth, you would see that it's a very complicated motion, and this is why 500 years ago Tycho Brahe and many others observed the universe and tried to figure out what was the motion of all the planets, of course, around the Earth, because they were observing from the Earth. They finally get to the conclusion after many data that all the planets are rotating around the Sun in an elliptic orbit. But from the Earth, the orbit of every planet is very complicated. Now we are going to study what are the motion concepts that we will use in this course. First of all, we talk about position. Position X. Position X means where is the object at certain time. What is the object at time t equal t1? Let's say that at time t equal t1, the object is in this position. What is this position? We will say from the observer is here. From the observer will say x equal to. Because it's the initial position, the observer will say x1, initial position, is x equal to. Object will appear there. Now, at time t2, the object will appear here, so the observer will say x2 equal minus 2. So this is at the time t1 initial, this is at the time t2 finally. So what is the displacement? The displacement of the object, of the person in this case, is x2 minus x1. So the object has performed a displacement of x2 minus 2 minus 2. So the displacement will be minus 4. So how to see the displacement equal minus 4? So the displacement is from t1 to t2, so he has performed this displacement delta x. There are 4 units, and the 4 units are moving to the left, so delta x is minus 4. So this is the displacement of the object. Then we will describe the motion. X will be position, delta x will be displacement or change in position, and the displacement on x will be x final minus x initial. can be positive or negative. Delta x can be positive if if the object is moving to the right, or negative if it's moving to the left. And the average velocity is delta x, the displacement in x, divided by the displacement in time. In other words, the average is x2 minus x1, the displacement, divided by t2 minus t1, the displacement in time, t2 minus t1. The other equation that we will use very often, it would be analysis that x final will be x initial plus delta x. This will come from this equation delta x equal x final minus x initial. X final is x initial plus the change in x. So the final money that you have is your initial money plus the change. And the change can be a deposit or maybe can be a withdrawal. So you withdraw some money. So the change in x is what it makes that x initial will change and will be x final. So in our term, delta x is x at the time t2 minus x at the time t1. So x at the time t2 will be x at the time t1 plus delta x. From this equation, we can obtain this equation. So normally we will play like this. X at any time t final will be x at the initial time t1 plus the change. Perfect. Now I want to say that is in the same way that we talk about position x, we can talk about position y. So imagine that we have our observer. Here is the observer. The observer is at the 0 point. He chooses the positive direction to go up. So plus 1, plus 2, plus 3. So he will say that the position of this object is at y equal 5. And the position of this object is y equal minus 3. So he will say, let's say that at initial position is y1 equal minus 3. Let's say that the final position is y2 equal plus 5. What will be the change in y? The change in y when the object displaces in the y direction from here to here, he will displace 8 units. 1, 2, 3, 4, 5, 6, 7, 8 units in the positive direction. So the displacement will be equal plus 8 meters. That is the same that to do y2 minus y1. In conclusion, delta y is from initial to final position. This is delta y. It's 8 meters going in the positive direction. Now imagine we choose another observer, this one at the 0, he is at the 0, but he decides to choose the positive direction going downwards. So this is the positive direction going downwards. Let's say that we analyze the same problem like before. y1 was minus 3. So the object was here at minus 3. y2 equal 5. So the object finally is here at y2 equal 5. What is the displacement? The displacement is from the initial position to the final position. This is delta y. So delta y is 8 units. You move 8 units. 1, 2, 3, 4, 5, 6, 7, 8 units. So delta y is 8 units. In what direction? In the positive direction. But this delta y is different than the other delta y. This delta y is going downwards. Even if the data is the same, the delta y for this observer is 8 meters going down. If you see the other data of the previous example, it will see that delta y is 8 meters going up. Finally, if you decide not to use X or Y, and you decide to use the S direction. So S direction, this is the S direction. You may choose observer at the 0, so we place the observer, and we decide for this observer what is the positive direction or what is the negative direction. So we have decided in this example that the positive direction is when you see in this direction. When the numbers increase in this direction, this is the positive direction. So if you have an object that is moving through the S direction, let's say that he's moving from S equal 3 to S equal minus 2. If he's moving from S equal 3, S1 equal 3, plus 3 to S2 equal minus 2, there is a change in the position, but now the position is not X of Y, it's S. So delta S is S2 minus S1. So it will be minus 2 minus S1, 3. It will be minus 5. So the position will be delta S equal minus 5 meters, of course. So the guy will appear just here. He will appear at S equal minus 2. Okay, S equal minus 2. So the direction of the observer, the positive direction, is very important to know what is happening, to interpret the data correctly. So delta S in this case is minus 5 if you move from here to here. And now we say, what is the velocity Vs in the direction S? The velocity in the direction S is delta S divided by delta t. So let's say that the object is at S1 equal plus 3 when t1 equal 2 seconds. t1 equal 2 seconds. And let's say that S2 equal minus 2 meters when t2 is equal, let's say, 6 seconds. So what is the velocity in the S direction? Is delta S divided by delta 2. Delta x is from here to here. So delta S is 1, 2, 3, 5. It's 5. 5 in the negative direction is minus 5 divided by delta t. Delta t is t2 minus t1. Delta t is the time elapsed. The time elapsed is 6 minus 2, which is 4. So the velocity, average velocity in the S direction is minus 4 meters per second. The time delta t is always positive. Maybe we can see this time passing like this. We go like this, and now what is passing is the time 1, 2. The object is not, even if the object is not moving, the time is passing 1, 2, 3, 4, 5, 6. Delta t is always positive, and delta t will change, even if the object is moving, delta t will change in the same way. So this is about the time delta t that you will always consider positive quantity. Now we are going to study the equation of rectilinear lines in the plane y-x. First of all, we define the slope. The slope is delta y divided by delta x. Is the vertical distance between the 2 points divided by the horizontal distance between the 2 points. So let's go to do a small picture here. Maybe I can do the picture here. So This is the point x1, y1. And this is the point y2 and x2. The vertical distance, the delta y, is this thing. Delta y is y2 minus y1. You see that y2 is all this. y1 is all this. And what is y2 minus y1? Well, this from here, from the initial to the final position. This is delta y. And delta x is x2 minus x1. x2 is all this quantity. And x1 is all this quantity. And what is x2 minus x1? Is from x1 to x2. Delta x is this thing, delta x. So if we make the triangle, we'll see better. Do the triangle, draw the triangle here. This is the point P1, this is the point P2, this is delta y, this is delta x. And the slope, that is the same that to say the tangent of this angle, is delta y divided by delta x. So it's y2 minus y1 divided by x2 minus x1. With this, we define the slope of a rectilinear line. What is interesting about the slope of a rectilinear line? The thing that is interesting is that the slope is constant. You can do these things if you have the rectilinear line. You can do it for any two pairs of points, and the slope will be constant because the slope is measuring the tangent of this angle, the tangent of the angle, and the tangent of the angle never change because the rectilinear line go like this, and the angle never change. So delta y divided by delta x will never change. So if you do it like this, you choose this point, and this point, this is delta y, and now delta x is bigger, but the ratio delta y divided by delta x is constant, and we call this constant m, the slope. Perfect. So we have two problems. If the first problem is they give me a point, an initial point, and they ask me what is the rectilinear equation. The second problem that we are going to learn how to solve it is they give me 2 points, and from the 2 points they ask me, tell me the equation of the rectilinear line. We have seen all these ideas during class, but it's a good review, so you will be sure that you understand this. So the problem one is you give me 1 point, x0, y0, and you give me the slope. Let's say that the point is 1, 3, and the slope is 2. What is the rectilinear line? Geometrically speaking, it means for the first case, case A, case B, case C, we solve the equation. We solve, geometrically speaking, the solution. For the first case, for this case A, that the initial point is 1, 3, so 1, 2, and 3, you start here, and it says that the slope is 2. What it means that the slope is 2? It means that 2 is equal to delta y divided by delta x. So delta y is 2 times delta x. Whenever I move 1 meter, delta y will be 2 meters. So one step of 1 meter will produce a change in y of 2 meters, 4 and 5. So we'll go 1, delta y, 2 meters. So this will be delta y equal to, this will be delta x equal 1 meter. Let's say now that I'm here. So I have started here, I start here, Am I ending here? I do one step of 1 meter to the right, and because the slope is 2 meters, I'll go up 2 meters. So now my point is here. So now I want to perform another motion. Let's say that delta x now is 2 meters. So delta x is 2 meters. So I move to the right 2 meters. 1 and 2. When I move 2 meters to the right, delta y will be 2 times delta x. So if delta x is 2 meters, delta y will be 2 by 2, will be 4 meters. So I'll go up 1, 2, 3, and 4. So I was at the point 4. I was at the point 4 here. So I moved 4, I will end at the 8. So, and this point will be 4. So the new point, it will be 4 eighths. And the rectilinear will be this rectilinear line. So giving me the slope and the point, an initial point, I can construct the rectilinear line. But how to obtain the equation? How to obtain the equation is another subject that we are going to study. Can you practice B and C, please? It will be interesting for you. Okay, so try also this one. You start with the point 1, 2, you get a slope 3, and you see how to construct the rectilinear line. Or maybe try this one with a slope minus 1. So now delta y divided by delta x is minus 2. It means that delta y is minus 2 times delta x. So you go and you do a step of 3 meters to the right. So delta y will be minus 2 by 3. When delta x is 3, delta y is minus 6. So if you start at the point 1, 2, you start here. And if you do a step of 3 meters, 1, 2, 3, you start at the 4. So you do a step of 3 meters, you are here, and the delta y will be minus 6. Oh, minus 1, minus 2, minus 3, minus 4, minus 5. Oh, minus 6, you start here. So the rectilinear line will do like this. Oh, sorry. Let me do it as I should do. The rectilinear line will do like this. Now I can perform another step. Let's go to perform a step of 1. If I perform a step of 1, I'm now at the 5. But when delta x is 1, delta y is minus 2. 1 and 2. I will end at the point. So starting from this point, I go to this point, I go to this point. So now let's go to analyze the equation of the rectilinear line. How to obtain the equation of a rectilinear line in the problem 1 when they give me the slope and they give me 1 point. So the slope is delta y divided by delta x. The essential point here is that the m is constant. So if m is constant, whatever points I choose x and y, and x0 and y0, m will be constant for all x, and for all delta y and delta x will be constants. So delta y will be y final, y minus y initial. Delta x will be x final minus x initial. This x final is the corresponding x for this y. So the x final and the y final. So the m will be y minus y0 divided by x minus x0. Solving for y, we obtain y minus y0 equal m multiplied by x minus x0. Solving for y again, you will obtain y equal y0 plus m multiplied by x minus x0. So if we choose the point x0, y0 at the point 0, y0, so we choose the point when x0 is 0, the rectilinear line will be this one, and the equation will be easy. Easy equation, y equal y0, where y0 will be this distance, this height, plus m by x. So this is the equation of a rectilinear line. Oh, this equation, it will work. You can now try to solve this equation. Using this equation, obtain the equation of a rectilinear line that passes through the point 1, 2 with a slope equal a slope 1. Now there is another question. What point is the intersection point with the x-axis? Okay, and now we get a question. C. What point is the intersection point with the y-axis? So solve this problem. In this particular case, I give you 1 point. I'll give you the slope. You know already the equation. That may be a... Now, for the problem 2 is I give you only 2 points. With 2 points, you can draw the rectilinear line that pass through the 2 points. Let's say that these are the 2 points, x1, y1, x2, y2, and you can draw the rectilinear line. What is the equation of this rectilinear line? The equation of this rectilinear line is obtained in the following way. We have the 2 points. So if we have the 2 points, the first step is, can we find the slope? The slope is delta y divided by delta x. Makes always the triangle. Pay attention to this triangle. This is delta x, and this is delta y. And this is delta x. Let me put the arrow to the right, because delta x is x2 minus x1, and delta x will go to the right in this case, and always we will use the independent variable x or t as delta x positive. And in this case, delta y will go up, so I will put the arrow like this. So step 1, find the slope. You have 2 points, you can find the slope, delta y divided by delta x. So if you find the slope delta y divided by delta x, now you go to the solution for problem 1. You have the slope and you have 1 point. Which point? This one, P1 or P2? It doesn't matter. 1 point. It will be the same result. So from the fact that m is constant, you will write m equal m by delta x. So delta y will be y minus y2 equal m by x minus x2 will be the delta x, or maybe you write this equation, y minus y1 equal m multiplied by x minus x1, and you will obtain the rectilinear line that pass through the point P1 and P2. Okay, so exercise we have done at class, you repeat it. Something similar we have done. So if m equal 2 and the point P is 2, 3, what is the equation of the rectilinear line? Easy. And the second one, if I give you 2 points, this point, 1, 2, and 3 minus 6, what is the equation of the rectilinear line? You do it. You can do it, for sure you can do it. Now there are 2 additional questions. Imagine that I give you this equation. I might ask you, what is the slope here? The m. The m is always what is next to the x, multiplied to the x. The slope in this case is m equal 5. The other question that they can ask you is, what is this, when x equals 0, what is this distance? Well, you place x equals 0 here, and for this particular equation, y equals 3. So this distance in this case is 3. So the cutting with the y-axis will be at the point 0, 3. And what is this point? How you will obtain this point? The cutting with the y-axis. Well, same, you will put for the y0 and you will solve for the x. So in this case, from this equation, you will say 0 equals 3 plus 5x. So minus 3 equals 5x. So x equals minus 5 divided by 3. So this point is the point minus 5 divided by 3, 0. So this point is the point minus 5 divided by 3, 0. So the information of the slope is always here, multiplied by the x. Okay. What happened with this equation? 3 plus 5x minus 2. This is another thing that you have to know. Imagine that you have the equation y equals 3 plus 5x. And you draw this equation. Let's say that I draw this equation. When x equals 0 is 3, so this is 3. When x equals 1 is 8. X equals 1 is the point 8. Well, let's say that 8 is here, so it's this point. So the rectilinear line is this one. This one. Okay. This is the rectilinear line that passes through the 2 points. Now imagine that I give you this equation, 3 plus 5x minus 2. How you will draw this equation? To draw this equation, you will displace to the right 2 units the graph. So this equation is an equation that is parallel to this equation, but it's been translating 2 units. So I will take, for example, this point, and I will move the point 1 and 2, so I'm now at the 2, 1 and 2, and I will draw a parallel line to this line, and this equation is 3 plus 5x minus 2. Wow. So when it appears the term x minus 2, it means that you translate the equation, you translate the draw of the equations parallel 2 units to the right. What happens if the equation will be y equals 3 plus 5x plus 2? You move it 2 units to the left. You can check it. You can draw this equation, and it will be the same one that minus 1, minus 2. This is the point minus 2, and I will place a parallel line to this equation. And this is the equation 5x is the equation y equals 3 minus plus 5x minus 2. Interesting. So let's go. So you have a summary. A summary now. Now we go why I want to study this rectilinear line, the equation of the rectilinear line. Imagine that now what you have learned, you put it on this term. Instead of the y, you put the x. Instead of the x, you put the t. So you are changing the y by the x, and you are changing the x by the t. So what will be the equation of a rectilinear line in space-time? Well, if y is equal y0 plus mx, I change the y by the x, I change the y0 by the x0, and the m that was y2 minus y1, the m was y2 minus y1 divided by x2 minus x1 will change to x2 minus x1 divided by t2 minus t1, because the y is changing by the x, and the x is changing by the t. So this is the slope of the graph. The slope of the graph, you make the triangle, and the slope is delta x divided by delta t. The vertical distance divided by the horizontal distance. So the equation of motion of a rectilinear line, on an object that is moving in a rectilinear line, but the rectilinear line doesn't refer to this line, it refers to this line. So the interpretation is that the object at t equal t1 is here. At t equal t2, the object is here. So the object is moving, it's displaced at delta x from x1 to x2. So the equation of the motion of the object in terms of x and t is this equation. That x of t is x initial, we can put x initial, or x1 plus m minus t minus t1. Or you can put it x of t equal x0, if you prefer, plus m by t minus t0. It's the same equation, they are mute variables. Now we are going to solve this problem. We are going to graph x of t, the function where say where is the position at every time for this problem. And the problem say you walk from home, so home is here at the 0. This is home, and you walk from home 1,000 meters, and it takes you 1,000 seconds. So you will be here if you walk at a steady state, and a steady velocity, a steady speed, means that your velocity is constant. So you go from here to here, so the velocity, the graph of the position versus time should be this graph, okay, this graph. So what it say, this graph? It say that when you are when it has happened 1,000 seconds, you are at 1,000 meters. Initially, at 0 meters and 0 seconds, the clock have not started, you were at this position. When the clock happened to vary 1,000 seconds, you are at 1,000 meters. If you move with a constant speed, it means that when you have traveled 500 meters, the time will be 500 seconds. So you are moving at certain speed. What is the slope? The slope of this graph is the velocity. And the velocity is delta x divided by delta t. What is delta x? Delta x is from x equals 0 to x equal 1,000. So it will be 1,000 divided by delta t. Delta t is from t equals 0 to t equal 1,000. Divided by delta t, 1,000. So the velocity is 1 meter per second. You are walking in this first step in the first part of the problem at 1 meter per second. Now the problem say like this. You walk from home at 1,000, it takes you it takes you 1,000 seconds, then you stop to rest for 100 seconds. So if you stop to rest for 100 seconds, so means that you are not moving. So means that the slope of the graph have to be horizontal, have to be zero slope, means that you are here at this position all the time during the next 100 seconds. So the graph must be like this, must be like this. Okay, so after the 100 seconds, you start to come back home at the same speed that you were going in the previous step. So you were going at 1 meter per second, now you go at minus 1 meter per second. It means that in every second you approach home 1 meter. In every second, 1 meter. So what will be the graph of x as a function of t? So the graph you will go at 1 meter per second minus 1 meter per second because you are coming back home, minus 1 meter per second. And the problem says that when you are at the position x equal 500, you decide to rest. And you decide to rest for about another 100 seconds. So you decide to rest means that you are not moving. It means that the slope of the graph has to be zero. So it's an horizontal graph. Now that you are not moving, you come back home at the same speed. At the same speed means at the same slope. So if it is at 1 meter per second, minus 1 meter per second. So you come back and you come back home. So the slope have to be parallel to this one, to the previous one, because you are moving to the same speed. Apparently the graph will cross the axis at 2000, but I think it's wrong. Should be 2200. You can do it, because on the first step you delay 1000 seconds, you stop 100 seconds, stop. Later on you move 500 meters, you move all this distance from here to here, to 500. To 500, so it will take you 500 seconds to move. If you move at 1 meter per second, 500 meters will take you 500 seconds. So 500 seconds, you stop another 100 seconds. So you stop here 100 seconds, so 100 seconds, 100 seconds, and still you have another 500 meters to cover. So if you move at 1 meter per second, you will cover in 500 seconds, 500 seconds. So the total amount of time that you will need in the trip will be 1,000, 2,000, 2,200, so I'm not wrong. Here, this point should be 2,200 seconds. So once that we draw the graph of x as a function of t, there are questions that we need to ask. The first question that we need to ask is, how far did we walk? This is related with the space, how many distance we have walked. And if you go to the previous graph, you will see that the distance that you have walked is 1,000 meters going in the positive x direction, and you walk home, so you walk a total distance of 2,000 meters. So this is the distance that you walk. You walk 2,000 meters. So 2,000 meters is the quantity of distance that you walk. It's not the displacement. We'll see what happened with the displacement. Sometimes the distance that you travel is the same as the displacement, but sometimes there is not at all. So how fast did you walk? This is related to the speed. And the speed that we will denote like v like this is not the velocity, it's the magnitude of the velocity, is the distance traveled divided by the time. So in the first step, when you go from home to the university, you walk 1,000 meters and you delay a time t of 1,000 seconds. So the speed is 1 meter per second. Is something same as the velocity. It looks the same, but it's not the same. We'll see why it's not the same. If you take in account the time that you take from, if you want to find the speed in the whole trip, going to the university and coming back, the speed going to the university will be the distance traveled divided by the time that elapsed to go and back. The distance traveled is 2,000, and the time elapsed is 2,200 seconds. So the speed in this case is 20 divided by 22 meters per second. And this is the speed going from the initial, from home to home. And this is the speed going from home to the university. If you calculate the speed going from home to the university, but taking in account that you stop for 100 seconds, your speed will be the distance traveled divided by the time. The distance traveled is 2,000, and the time that elapsed will be 1,100, so your speed will be 20 divided by 11 meters per second. The other question is, what is the average speed? The average speed is the distance traveled that is always positive divided by the time, total time, that is elapsed in the distance travel that you take for. Now there is something that is different. What is the velocity? Velocity is displacement divided by time elapsed by delta t. Velocity is delta x divided by delta t. So what is the velocity from going from home to home? The velocity from going to home is the displacement, but the displacement is you start at certain point at home and you come back at home. So the displacement is 0. 0 divided by the total time is 2,200. This is 0. The velocity is 0 from going to home from home to home. Meanwhile here, the speed, that is a different concept, the speed going from home to home is 20 divided by 22 meters per second. So the displacement in the whole trip is 0, and that makes that the average velocity is 0. So it's different, the velocity from the speed. So the distance is always a positive quantity, and it doesn't care in what direction you are moving. It's always adding and adding and adding steps that you walk. If one step is 1 meter, distance in meter is the number of steps that you do. Meanwhile, displacement is different. The displacement can be positive and negative. The displacement care about in what direction you are moving. So the velocity is displacement divided by the time. So it's a different concept. The average velocity. Velocity, when we say velocity and average velocity, we mean the same thing. So as a conclusion, we know that the speed is distance over time. Speed is distance over time. The distance is always positive, and the time is always positive, so the speed is a quantity that is always positive. Speed doesn't care about direction. Now with velocity, always average velocity, it can be positive, the average velocity can be zero or can be negative. And the detail of the motion is irrelevant. What it matters is the displacement over time. The average velocity depends on the interval of time that you choose. So the velocity, the average velocity is displacement divided by the time. And the unit of velocity is meter per second. And this is the slope of the graph x of t. V is the slope of the graph x of t. Now we go to the idea of instantaneous velocity. The idea of instantaneous velocity is the same idea as average velocity. Imagine that you are at this point. This point is the point x1 when the time is t1. And this point is the point x2 when the time is t2. So what is the average velocity? The average velocity is you make a triangle here, you connect the 2 points with a rectilinear line, and you say, what is the average velocity? It's the slope. It's the slope. So it's delta x divided by delta t. This is the average velocity. And what is the instantaneous velocity? The instantaneous velocity is when this point is approaching t1. So you are here. So now you will construct your triangle like this. And you will say the average velocity is delta x divided by delta t. Oh, if you move this point instantaneously, doesn't mean delta t equals 0. It means that delta t tends to 0. So if you move this point very near and you make this delta t very, very small, then you consider what is the instantaneous velocity. And the instantaneous velocity is the slope of the graph. So on here, the instantaneous velocity is the magnitude of the slope. On here, the instantaneous velocity is the magnitude of the slope. Oh, it's 0. On here, the instantaneous velocity is the magnitude of the slope. Oh, it's negative. So the instantaneous velocity is a process that is a limit. It's the limit when delta t tends to 0 of delta x divided by delta t. And this is for calculus, and we don't use calculus, but the idea, you need it. You need it to solve the problem. So the idea is makes delta x divided by delta t when delta t is very small. Delta t tends to 0. And you will find a triangle that the slope is this one. And that's all. What is the acceleration? The acceleration is the change in velocity per unit of time. It's measured in meters per second squared. And what is the change in velocity? This change in velocity is v final minus v initial, v2 minus v1. So the acceleration is v2 minus v1 divided by t2 minus t1. Let's go to write it. Acceleration A is v2 minus v1 divided by t2 minus t1. Or in other words, delta v divided by delta t. And what is instantaneous acceleration? So you have the graph now, not of x, v as a function of t. Okay, and what is acceleration? Let's say that the graph is like this. So the v increase in this graph. The velocity increase. Forget about position now. We are talking about the velocity. It has acceleration. Well, the acceleration is the change in velocity per unit of time. And what is the acceleration here? Well, suppose this is v2, suppose this is v1. You make v2 minus v1, make this triangle. This is V2 minus V1, and this is T2 minus T1, delta T. And the acceleration is again the slope of the graph in a graph V versus T. So the acceleration is here is like this, the graph, the tangent to the graph. So from this point, you can make a rectilinear line, and the acceleration is this slope. From these 2 points, the average acceleration is the slope. From these 2 points, the average acceleration is the slope. And the instantaneous acceleration is exactly the same idea. You make V2 to be very near of V1 in a process that to take the limit when delta T is 0, tends to 0. It's not 0, never 0. Tends to 0, approach to 0. In this moment, you calculate the slope, and this is what you calculate is the instant acceleration. So meter per second is the acceleration, because delta V is meter per second. It's maybe 5 meters per second minus 3 meters per second is 2 meters per second. 2 meters per second divided by second. But what does it mean plus 5 meters per second squared? Here it said what it means. It means that in every second, 5 meters per second square is 5 meters per second. And it means that the change in velocity per unit of time is 5 meters per second in every second. It means that if you start with V equal 100 meters per second, and you have an acceleration of 5 meters per second squared, it means that in every second, your velocity will change in 5 meters per second. So if you start with 100 meters per second, in every second, you will be added 5 meters per second. So after t equal 1 second, your new velocity will be 105 meters per second. When t equals 0, your velocity was 100 meters per second. Acceleration means that you change your velocity, and you change your velocity in 5 meters per second every second. So in t equal 2, your new velocity will be 110 meters per second, because you change your velocity in 5 meters per second every second. Every second from here to here is 1 second. So 5 meters per second square, acceleration 5 meters per second square, means that you increase your velocity in 5 meters per second in every second. What it means minus 3 meters per second square? It means that if you start with V0 equal 100 meters per second, and your acceleration is minus 3 meters per second square, it means that in t equals 0, your velocity is 100 meters per second. After 1 second, your velocity, new velocity, have decreased in 3 meters per second. So your new velocity is 97 meters per second. After another second, t equal 2, your new velocity will be 3 meters per second less. So it will be 94 meters per second. But this is the equation of a rectilinear line, because the slope, that is the acceleration, is measured how much you increase or decrease per second. Okay, so velocity, so the summary is velocity is the change in x divided by the change of time. This is the velocity, the average velocity, and acceleration or average acceleration is the change in velocity per unit of time divided by the change of time. This is the graph. if they ask you, for example, which of these graphs have a bigger velocity? Well, of course, that this graph have a bigger velocity because if I take 2 points, let's say this point and this point, on this interval of time, delta t, the first graph has only increased delta x this small displacement, while for the other graph, the displacement in the other for the other graph, the displacement is all of this. Delta x is bigger. So the average velocity is bigger for this graph than